Now, I want to deal with this particular question. The question goes thus: let G be a group with the identity element E. If A squared is equal to E for all A, B belonging to G, prove that G is abelian. Now, a group is said to be abelian if it is commutative. An abelian group is a commutative group. So, it suffices to show that for all A, B in G, then A dot B is equal to B dot A. So that is our main objective. We want to show that this particular group is abelian. And I said earlier on that an abelian group is also a commutative group. So what I'm saying in essence is that now since A squared is equal to E, what does that imply? It implies that A dot A is equal to E. So if A dot A is equal to E, what does that imply? It implies that A is equal to A inverse E. Because if this comes to this side, that means A is equal to A inverse multiplied by E. So which in turn implies that A is equal to A inverse. So thus implies that every element is its own inverse. Similarly, if B squared is equal to E, so we can also say that B dot B is equal to E. So what does that imply? It also implies that B is equal to B inverse. So that implies that every element is its own inverse. A is equal to A inverse, B is equal to B inverse. So that implies that E is equal to AB all squared. So if E is equal to AB all squared, so we can interpret this as AB dot AB for all A, B belonging to G. So what does this imply? It implies that E is equal to A into B, AB. Then it implies that E is equal to A into B, AB. So that implies that A inverse is equal to B, AB. If this comes to the left hand side, that implies that A inverse is equal to B, AB. So if you now pre-multiply, correctly, multiply. We multiply both sides by B inverse. So if I pre-multiply this particular expression by B inverse, that implies that B inverse A inverse is equal to B inverse B of AB. So B inverse A inverse is equal to B inverse B in brackets AB. So what does this imply? It implies again that B inverse A inverse is equal to E into AB, because B inverse B is an identity element. So now, since we said earlier on from Adam, we said from Adam that every element is its own inverse. B is equal to B inverse, and A is also equal to what? A inverse. So that that implies that this B inverse here, I will replace it with what? B. So B inverse becomes B. Then my A inverse here becomes what? Becomes A. So BA is equal to AB. So that is our assertion from Adam. We wanted to show that where AB must be equal to BA. So hence, since AB is equal to BA, then G is Abelian. So that is the end of today's class. So life is continuous, it is differentiable, it is integrable but not measurable.